In this example, we're going to solve a complex equation. We're asked to express the square root of 5 plus 12i in the form a plus bi. Let us create an equation. So let us say that a plus bi equals the square root of 5 plus 12i. And see, can we manipulate this to solve? Well, if we square both sides, so we square the binomial a plus bi, so square the first term, multiply the two terms and double it, and square the second term. And that equals to 5 plus 12i. Now we know that I squared is -1, so we end up with negative b squared in that term. This is a complex equation, so the real parts must equal, giving us that a squared minus b squared is equal to 5, and the imaginary parts on the left hand side must equal imaginary parts on the right hand side, giving us that 2abi must be equal to 12i, or 2ab is equal to 12. Dividing across by 2b, we see that a is equal to 6 divided by b. Now we want to solve this system of equations. To solve a quadratic and non-quadratic type equation, we'll substitute. So we'll replace a squared in the blue equation with 6 over b to be squared. Expanding this, we get 36 over b squared minus b squared is equal to 5. If we multiply across by b squared, so that we have no denominator, we see 36 minus b to the power of 4 is equal to 5b squared. And express this in a more traditional quadratic type form. So we have b to the power of 4 plus 5b squared minus 36 is equal to 0. This is a quadratic equation, or a degree 4, but we solve it like a quadratic equation. So we're going to factorize it. It's a straightforward one. We can do it by inspection. The factors of b to the power of 4 are b squared by b squared. The factors of negative 36 are 9 and negative 4 that add up to positive 5. This gives us two possible sets of solutions. Either b squared is equal to -9, but this is not possible because we're told at the start that a and b are real numbers. And if b squared was 9, well then b will be plus or minus the square root of -9, and that's not real. And the other option is that b squared is equal to 4, giving that b is equal to positive or -2. So these two solutions are real, they're possible. So we could take these solutions and substitute it back into the pink equation that a equals 6 divided by b, giving solutions for a. Now we could probably do this all at once even, so it's 6 divided by either plus or -2, positive or -2. And if it's positive, we're going to get positive 3, and negative, we get -3. So we seem to have two solutions. So we have two pairs. So a and b are either both positive or both negative. So we can say at the end that the square root of 5 plus 12i is equal to either 3 plus 2i or -3 -2i. And there's our solutions.